Today we are going to talk about scientific integrity in the open science. I kind of assume that science is now kind of open, more open than it used to be, at least. And so I will talk to you a bit about the link between scientific integrity, open science, and pretty much also perspectives on scientific integrity linked to I know the current technological ecosystem, or well, I'm trying not to spoil you too much, but you'll see what I will talk about very quickly. So just to come back to where I'm from, because so we're in this webinar thanks to the Circle U Alliance, and so I'm from Université Paris Cité in Paris, and just for a little bit of information, but Paris Cité is actually a merger between two older universities, Diderot and Descartes, and so it's a pretty big university in Paris. So there are 62,000 students, undergrad, I think, and 3,500 graduate students. So it's a big university. And here is the headquarters where I work. And so as you can see, it's pretty old. So I wanted to ask you guys, where are you from? So I listed all the university from Circle U, but obviously if you're from somewhere else, you can enter other. Last time there were a lot of people from Belgrade and Pisa, and a few from my university as well, but I see that it's pretty much the same thing today. People from Oslo as well. King's College, UC Louvain. I see Pisa in the chat as well. Okay, so a lot of people from Pisa, I see, and University of Belgrade, and a few others from other university. And there's one person from my university as well. Okay, so I'm going to go to the next slide just to ask you if you are a master's student, a PhD student, postdoc, a tenured researcher. Congratulations if you are, or just someone with a different role as I am, because I'm a research librarian. Obviously, if you're just here because you're curious, just write other. Okay, a lot of PhD students and postdocs as well. So I didn't say that when I started, but I have a PhD in cognitive psych, and I did a postdoc as well. So I share your struggles and the difficulties to navigate navigating all these issues about scientific integrity, open science. So okay, a lot of PhD students. Okay. And just to know in which discipline are you working in, stay general. I mean, it's just to know what's your discipline, but I may not understand your PhD topic, obviously. Okay, earth science, education, history, medical chemistry, linguistics. Okay, and materials. Well, I'm always glad to see that open science actually is of interest for every PhD student. Basically, law, economics, philosophy. Yeah, so I'm glad to see people from all disciplines. That's great. Well, that's awesome. Archaeology, agriculture, computational chemistry, soil chemistry. Okay, well, thanks so much for answering. I hope that regardless of where you're from, you're going to find something interesting and useful for you here today. So just to let you know what I'm going to talk about pretty much today. So we're going to talk about how open science practices help fostering scientific integrity. And so I'm going to talk about pretty classic challenges in scientific integrity and how open science actually helps for that. But so that's pretty much the past or today. I mean, in terms of what kind of scientific integrity challenges we're actually trying to fight. How increasing, and then we're going to talk about how actually open science actually comes with new challenges as well to scientific integrity, and that will be more about scientific publishing. And so I'm going to talk about predatory publishers as I talked during the Wednesday webinar, but I'm going to talk about other type of issues that are linked to publishing, but the pose new threat to scientific integrity. And also I will end by talking a tiny bit about obviously about new challenges and to scientific integrity, and that are linked to technological developments. And I will talk about large language models, chatbots. So if you're familiar with ChatGPT and large language models in general. So just to tell you a few words about open science, what it is, if you're not that familiar with, I mean, what it entails. So that's a European definition of by Foster. So open science is the practice of science in such a way that others can collaborate and contribute, where research data, lab notes, and other research processes are freely available under terms that enable reuse, redistribution, and reproduction of the research and its underlying data and methods. So the idea of open science is opening the scientific processes, but it's not just accessing them for free. There's also a big question of how reusable they are, how they can be reused by others, and how we can actually build a science that is cumulative thanks to open science. It's not just about having things for free, if that makes sense. So in France, we have a plan that is a guide for institutions. So so we're not our second national plan for open science, and the definition that is given in our context, but it's pretty much the same, but it emphasized the unhindered dissemination of results, methods, and products for scientific research. And it emphasized also the fact that this opportunity is provided by digital progress to develop open access to publication and data, source code, and methods. And that's pretty much a way to say that thanks to the digitalization of pretty much everything, it's easier now than ever to actually open science and scientific processes. This, I'm not going to go into the detail of that, obviously, but it's just to show you that for any scientific process, there's basically an open side of it. And so there's open access, obviously, that is pretty famous in terms of what, I mean, it's a big part of open science, historically speaking, but also open data. So meaning that, for example, you can actually have we will see a open component of like what you do with your data, but also open workflows, open guidelines, your open bibliometric indices, open repositories. Pretty much everything that is involved in the scientific process has an open component. So that's pretty much it. And so so there's so much in open science. So that's also why I come back to that, is because it's perfectly okay not to know everything about open science. I do not know everything about open science. It's changing all the time. But so there are, it may be an open component of anything you're thinking about in the scientific process. So open science is a worldwide movement for knowledge dissemination. It actually encompasses a plethora of activities in many domains, and from publishing to software development. Citizen science is also involved, and it's a beneficial practice. And I'm pretty much going to actually explain to you why it's a beneficial practice. And so I'm going to come back right now to kind of a bit of a history, the recent history, but of scientific integrity struggles and the way open science can actually be beneficial and is beneficial to not do these errors in the future. So when we're talking about scientific integrity, so there's a scientific literature on scientific integrity, and this literature pretty much agrees on the fact that scientific integrity is not a black or white set of practices. It's more of a spectrum of scientific behaviors. And at one end of the spectrum, you have fraud. So what is considered as fraud, and pretty much everybody agrees that fraud actually encompasses plagiarism, falsification, and fabrication. So these are frowned upon, universally speaking. This is considered as bad behavior and condemnable behavior in a lot of countries. And on the other side of the spectrum, you have something that would be considered it's just the opposite, as what we call responsible research practices. So practices that foster scientific integrity. And in the middle, you have what is called questionable research practices in the literature. And questionable research practices describe behaviors that go from genuine research misknowledge to intentionally bad practices. So it actually encompasses, again, a very different type of behavior in terms of the volition involved. Like you can actually have questionable research practices whether you want it or not. Like you have a lot of different behaviors falling into this category, and this definition is evolving because there are always new behaviors that we didn't know about, or behaviors that we question now and we didn't question before. So that's pretty much where we are in terms of defining scientific integrity. So questionable research practices are a big issue in scientific integrity, and are kind of the focus on a lot of scientific integrity trainings, for example, for PhD students, and I give some of them because it's maybe easy to understand how fraud is not a good scientific practice. I mean, that kind of makes sense, but it's sometimes complicated to know how questionable research practice can actually be a problem and why it's a problem. And just to tell you that questionable research practices are prevalent across discipline and countries. This is not just happening in some disciplines. It's pretty much something that is debated and present in a lot of disciplines. And it's also something that is prevalent across research roles. There's been 2 years ago a survey, research integrity survey in the Netherlands that has shown that actually the people struggling the most with questionable research practices are PhD students, because, well, there's a pressure, obviously, in being a PhD student. And so it's very often your first research role, and it's actually pretty hard for a lot of them to reconcile good research practices with what is sometimes, I don't know, kind of on the fringe. So yes, I just wanted to show you that because it's actually something that is prevalent and that is, I mean, we need to talk about. Where is open science in all of this? So open science has a complementary relationship with other type of behavior or practices in the research integrity ecosystem, if we could say. So there are papers, and I'm talking about this paper because I think the image it does pretty neat. But the concept of open science and rigorous conduct of research and transparency kind of go together to actually work on scientific integrity. They all foster scientific integrity in different ways. And open science, for example, is more about the dissemination of the research input. And so by helping the dissemination, you actually make research more ethical. But for example, conduct of research will be more, I mean, the type of behavior as stated will be more about rigorous research practices But so each type of practice is actually linked to a different step in the scientific process, but they all contribute to scientific integrity. And so open science is kind of it's part to play. It has a part to play in actually in scientific integrity. It's not going to solve everything, but it definitely has something to do with fostering scientific integrity. Why should we even care about open science and how it could actually help? So in the 2010s, especially, so in the recent past, there have been famous cases of replication crises, and the most famous one being the psychology one. So in the early 2010s, group of researchers tried to replicate 100 high-profile psychology findings to actually see if these research were replicable. It's actually a big question in psychology, but in every science, to know, well, if our results are actually robust. And so this reliability study didn't go up the way we hope science to go, meaning that the vast majority, 61% of the study did not replicate original results. And as you can see, the black square, the results that are not at all similar to the original results, and that's like 15%. So that's a lot. Following this, we've been talking in psychology about a replication crisis, meaning that a lot of our results were actually probably not false, but not robust, and pretty much due to statistical chance, if we can say. And so the question is, what can we do to actually make that better? Because that's pretty much the foundation of the science that is not robust, if we could say. The thing is, it didn't happen only in psychology. The problem is it's widespread issue. And so the Center for Open Science, which is the group of scientists that did the psychology replication project, also worked on, so not the same, but also they led this reproducibility project in cancer biology that didn't go very well too. And I thought it was interesting to see on their website that some of their stats actually tell something about how open science can actually make this better, because a lot of the cancer biology studies were hard to replicate from the start because of a lack of access to a lot of information needed to replicate. And for example, 0% of the studies that were selected had a totally described protocol, meaning a protocol that that was enough to actually replicate the STEM study. 2% only had open data, so pretty much no way of rerunning statistics on no available data. And there was a need to ask for key reagents in the vast majority of studies. And as you can see in the bottom, 32% of experiment had the original author were not helpful and unresponsive, and so that's also a problem. So, and very recently, in the last 5 years, there's been a looming replication crisis in machine learning based science, and that's a problem because it actually it's not just, it's machine learning science, so it's not in machine learning, but it's actually across the scientific spectrum. And the thing is that it also partly is based on the fact that there's some kind of I don't know what to say, not obscurity, but it's not easy to know what was in the training data. So there's a problem with that as well in machine learning right now. These two papers are from 2022, so that's a problem that is happening currently. So the cause for the replication crisis or crises, because there's not just the psychology one, a few possible explanations have been proposed, and they make sense in terms of why am I talking about them? It's because they actually can partly be solved by the use of some open science practices. And so a few explanations include the positive publication bias, meaning the tendency of scientific journals to actually only publish statistically significant results. So I guess you're familiar with that. And the fact that it's not very, it's not easy to, it's still not today, not easy to actually to publish replications or negative results. Obviously, there are questionable research practices like fraud or data snooping, and pretty much what I've told earlier, the fact that we don't have access to either the method or the data, and so we cannot replicate. Here you have an example in Nature of a survey that for scientists, things that contribute to irreproducible research, and that's pretty much things that we've talked about. There's bad luck at the bottom, but there are much more things than just bad luck in the fact that scientists cannot replicate experiments and results. So why can open science actually help with this? Because if for any given experiment, the rational data sets and methods are available, then we can constantly reassess the robustness of scientific research. For example, by, okay, someone is writing on the screen. Attempt to replicate the original experiment. So for example, you can rerun the original method. We can reanalyze the original data. That can also help you to avoid wasting time because you're exploring a counterintuitive result that looks promising but was actually from statistical chance, and you can identify scientific misconduct, which is also useful, obviously. And here is an example. So it's an example from so Diederik Stapel. Diederik Stapel was a professor in social psychology in the 2010s. I mean, even before, but he was pretty famous. He published in Science, so which in psychology is not easy. And so he was very high profile, but he was actually a fraudster in very dramatic sense, because so you have here cite a quote from his autobiography, which I thought was interesting to put in comparison to the committee report, the committee that actually look at his fraud in detail. And so because basically he was saying that he would sit in front of his computer, just open Microsoft Excel and just write data. And so that's basically fraud. But the thing is that the committee report kind of says that they had to examine the possible fraud with the original data sets and with what they have. They don't really know. I mean, they know because some things are copied, but in some cases it's kind of harder to know about. And so the fact that you have the data after everything, I mean, if the data were asked for publications at the time, maybe that would have helped kind of spotting these problems in the data matrices. And another example of that is that, so as you probably know, when a paper is not accepted anymore by the scientific community for various reasons, articles are retracted, meaning they're kind of canceled. And so the main reason for that is still misconduct today. So studies that you have studies that study retractions, and they show that the main reason for retraction is misconduct today. So the thing is that it's after the fact, so meaning that the paper was published and then peculiarities were spotted in either the method, the peer review, or other things. But what is interesting is that it's pretty much easy to be sure that a paper is retracted because of plagiarism. So actually, it's easy to know that a plagiarism is misconduct, pretty much in 100% of the cases of retraction where it was for plagiarism. We could be sure that it was a misconduct. Pretty much same thing for the review process compromise. So when the peer review process, so when the retraction is due to review process, we can actually judge that it was a misconduct in 100% of time. And so it's something that we can actually see and spot. But for example, for data issues, it's much harder. And so accessing data or asking for data along the entire process may actually help. And you see how transparency here is key. And I'm just going to give you a few ways that actually open science can help across the entire scientific, research process to actually avoid this type of problems. And for example, something you can do is pre-register your study. So pre-registering is pretty much saying that you're going to run an experiment on this and this and this, and that you expect this and this and this, that your hypotheses are A and B and C, and what you're going to do. This is not something that it's not, as you say here, it's a plan. It's not a prison. It doesn't obligate you to do anything. It's just a way to be transparent about what you're trying to do. And it's actually a good practice as well, because it actually helps to put a timestamp on your idea and say, well, I'm working on that. And so it can help definitely with plagiarism along the way. Another way to actually making data and scientific statistical processes more transparent is to actually publish studies as a registered reports. So registered report is a publishing format. It's not a journal. It's a published format that that's been adopted by more than 300 journals, and the most recent one is Nature. I think it was last week or 2 weeks ago. And so you can actually submit registered report to a lot of journals. And in registered reports, you have basically two peer review stages. And you have one after you develop and design your study, but before data collection. So if you are accepted at this stage, you are accepted regardless of whether your experiment will work or not. And that's pretty important because it also helps you not to develop ad hoc hypotheses to actually fit your data better. It's more transparent because it helps you to tell a story that is actually what is happening and not what you would have liked to happen. And it's, even if your experiment doesn't work, you still have a publication. So it's actually something to consider. So you have a second peer review when you write the report to be sure that the report is in the right format, but the acceptance actually depends on the study design and not on the data. Obviously, a few other ways to actually treat better with data better is to learn about data management. A big part of open science is dedicated to learning about the data cycle, learning about FAIR principles, which is making data findable, accessible, interoperable, and reusable. And I'm just also added the data DMP templates that we have of data management plan, which is a document that explains very much the life cycle of your data, and that is asked more and more by research funders, especially by the European Commission, and national funders actually ask for DMPs very often now. And that's actually, even if you don't have to give a DMP, it's actually pretty good practice because it actually kind of helps you figuring out what you want to do with your data. If you want to reuse them, how do you want to store them, and how do you want to describe them as well, which is pretty important. And so it can help with adding transparency to data. And obviously a few other ways is by making your workflow more open, by using software that actually are interoperable, open source, seeing that, that help people actually not having to spend a lot of money to rerun experiments. So that's pretty much part of the open science way of life, if I could say, but also helping assessing the robustness of results. So I'm going to talk now about new practices and new challenge that emerged from the spread of open science, and especially open access, and the scientific ecosystem. And so we're going to talk about how yes, the fact that we accept now open access pretty much as something that exists, and that the majority of publications are now open, actually created as well. And we should not, say it is not the truth, because it's actually what happened. It created an entire new market for actors that threaten or at least question scientific integrity, what it means and where it's going. And so I'm going to talk about that right now. So predatory publishing is pretty much what we think about when we think about problems in publishing today, especially open access. But so if you've been here on Wednesday, I talked about that in length. But so predatory publishing, the definition of predatory publishing is that this means that it's about publication that prioritize self-interest at the expense of the scholarship, and are characterized by false or misleading informations, deviation from best editorial and publication practices, a lack of transparency, or the use of aggressive and indiscriminate solicitation practices. So it's pretty much about the scientific rigor, but also about economic behaviors. There were a lot of predatory publishers on the Bell's list, which was a list of a blacklist of publishers that closed in 2017, and it has been estimated that there were 10,000 predatory journals in 2018, 420,000 predatory articles in 2014, but these are old numbers, and we may be around 15,000 predatory journals in 2023 today. The main characteristics of predatory publishers and journals is that they provide no or only peripheral peer review, they ignore editorial services for publication, and they often adopt deceptive tactics to entice submissions and compel payments. Where is that coming from? Why do we have a predatory publishing today? Pretty much, so if you've been there on Wednesday, and if you did not, you will have to, maybe rewatch what we talked about on Wednesday, but we spent a lot of time talking about the evolution of academic and scientific publishing, and the fact that there was what is called a serial crisis in the 80s, 90s, and followed by now an APC-based gold open access in the 2000s, and still today. And so now the majority of institutional actors actually pay for article processing charges, meaning charges related to publication, but that are paid by authors, so by scientists, to actually make the article open access. And obviously, the fact concurrently to that, we also have the fact that the globalization of digitalization of the internet went with the digitalization of academic publishing, and that you don't need to have distributors, you don't need to have presses to actually create your own journal now. You just need a server, you need a domain name, and you can do it. And you also have a lot of Western, like the publish or perish mentality of Western countries actually was imported in some developing countries, especially the need to publish in English. And that also contributed to the development of predatory publishing. So the Bell's list was the first list actually trying to keep a record of predatory publishers. So the list doesn't exist anymore because Jeffrey Bell was harassed by a lot of these publishers, and so it became increasingly difficult. Some mirrors still exist today, but you also have white lists of predatory publishers, and it's pretty easy to find online, but there is no list as there was for the Bell list today. And the predatory publishing definition is pretty hard to actually set in stone, because as it was the case with scientific integrity in general, you have pretty much a spectrum of what is considered predatory publishing. So you have pretty obvious predatory publishers, you have publishers seen as legit, and then in the middle you have publishers kind of playing on both sides, so basically having some economic practices that are or scholarly practices that are going to make them look high quality, and then they will have other economic practices, especially that are going to be pretty fraudulent. So it's not easy, and we talk about a gray zone of predatory publishing where you have publishers that may be considered mainstream, that actually a lot of countries are actually using a lot, but that are kind of in the middle of that. There are also predatory conferences. I encourage you to go and read this, because the journey into a predatory conference, because I think it pretty much summarizes what it is to go to a predatory conference. But today I wanted also to talk about in more detail about hijacked journals. So that's something that is maybe not very well known. I don't think it's well known. But so I was saying that it's pretty easy today to actually create your journal, but actually the phishing industry also moved to academic publishing, in the sense that you have a category of cyber criminals that are buying domain names of journals that forgot to renew their domain names, or to actually buy closed domain names or change their names. And so they buy their domain names, clone their websites basically, and so redirect APCs to their website. The problem is that it would be easy to spot if it wasn't for the fact that actually the Web of Science and Scopus sometimes actually register the hijacked website as the legitimate one. And so that also what actually pose a real threat to people actually trying to publish with these journals. So just here, for example, you have the example of Arctic, that is a journal published by the University of Calgary that has been hijacked at least once, because sometimes you can be hijacked several times. And so you can see that the website on the right is much less professional in this case. And so as you see, like they have arcticjournal.org, and so that sounds pretty legit. And journals websites are not known to be particularly super nice sometimes, so you don't really know, but you can maybe guess. But the thing is that if you type in Google Arctic Journal, the hijacked one is the first one. So it's really hard if you're not looking that well. But actually, sometimes it's even harder than that. So I'm giving you a pretty recent example of Linguistica Anverpensia, which is a linguistic journal from Belgium. And so they changed their names. They changed their name to actually make it longer. And so hijacker used this opportunity to register the old name. And the thing is that even after it was spotted and reported to Web of Science and stuff like that, well, it's still going on. And the thing is that in this case that I thought really interesting, so these screen captures are from today. So it's super hard to know which one is the right one. So the legitimate journal is the screen capture on the left, and so that's the website. And as you can see, the hijack version, you may be, I mean, it's super hard not, I mean, it's pretty much impossible just from the page. Actually, to know the difference, you have to go to the archives, and the archives are not the same. And on the hijack version, if you go to, I took, for example, 2021, that is not on the other website, you can see that there are articles that are from disciplines that are not covered by this journal. So this journal talks about translation, and it's only about translation. It's translation studies, basically. And here are, for example, things about common sports injuries and rehabilitation. So that's not, I mean, these articles are not from this journal, but are still considered sometimes in Web of Science as being, are from this journal. It's really complicated, and it for authors to actually find their way here. And the problem is that, for example, 10 papers of the hijack Linguistica on Verpienza ended up on the WHO COVID-19 database. They've been removed since, but so the damage was done, and some articles on these hijack journals ended up being on a database that was pretty important for public health. So that's a real issue. It's not easy for authors to actually find their way through that. Another very important issue in publishing today is are paper mills. So paper mills are basically a website where you can actually buy authorship on a publication that is being peer reviewed. So paper mills sell, so they produce fake articles, so and they sell you the authorship. You may think this is weird and I would never do that, but actually it's getting such an issue that the main publishers at least have entire departments investigating this problem. Just to show you what it looks like. So this is the main, the one, I'm not giving you the name here, but this is a Russian website. It's the main one. Because there's a main one for a main paper mill. And so if you go there, you can actually look for, so there are articles for sale. And so they are getting reviewed. They tell you the percentile, where they are going to be indexed, for example, Scopus. And so here you can buy the authorship. So obviously buying the first place is more expensive, and so it's in ruble, but it's basically 830 euros for first author here. So as I was telling you, this is a big issue in publishing, actually. This is a multi-million-dollar trade, and it's currently a big scientific integrity issue in open access publishing. And so, for example, Clarivate, that owns the impact factor, and the Web of Science is actually, I've been investigating this because, so this paper end up in legitimate journals. And how it works is that a group of authors submit a paper, and at some point, so they exploit a vulnerability in the publishing process that allow authors to add names to manuscript after acceptance. And so very often journals are like, well, we're not going to accept new authors at this point, but then in some journals, in the production offices, you have novice workers, people that are just right out of college, and they don't know it's necessarily a bad practice, so they accept. And so that's, they exploit basically vulnerability in the publishing process to make this happen. And why would you do that? Well, you would do that for a lot of reasons. For example, that the pressure is so strong because you need papers, and so why not? It's going to be in a legitimate paper journal, and so just why not buying this? And in some countries, actually, you have cash rewards if you publish. So it's actually also a reason to do that. And so now that I'm done with showing you the bad side of everything that is happening in open access, I'm just going to talk a little bit about the example of large language models and IA content generation on how, on new challenges for the scientific process. Meaning what I wanted to say here is that scientific technological advances actually also pose new threats or just new questions about what it means to have behaviors that respect scientific integrity. So it's just not necessarily bad or good, it's just that it asks new questions. And so I obviously want to talk about GPT and in large language model in general. So GPT is the large language model, and ChatGPT is the conversational layer, the chatbot that is on top of it. But I'm not going to get into what ChatGPT is or GPT. I guess you're familiar with that by now. There's an entire different question about what it means also for open science, in the sense that there's the big question of having the open source component of large language models, an entire question about should that be open source. The creators of OpenAI are currently saying that it was a mistake to be open source. And so there's a debate about the open source status of large language model that is pretty interesting for open science. But what I wanted to talk about here was more what kind of challenges to scientific integrity this type of scientific advances pose actually for scientists. And just a few things. For example, can large language model be scientific authors? Well, that's a question that is asked because at least 4 papers since ChatGPT has been launched in November listed ChatGPT as an author. And so at first, many scientists will disapprove, but there was no guideline. So that's a question that could be asked, and that was asked. And Science and Nature and the Nature group, so Springer Nature, updated the guidelines saying that you cannot list ChatGPT or large language model as an author of your paper. And in the case of Springer Nature, they also said that, but you can use large language model in the writing process, but or scientific process, but you have to disclose the use of large language model, which actually ask a different question. How useful are they for the scientific process? Should they be disclosed? Should they be used? And you have here an example of, here you have a Nature survey for scientists, like have they used chatbots like ChatGPT, and for what for? And so a lot of people use them for creative fun, but some people use them to help with presentation, conducting literature review, which is, I would say, a big issue because ChatGPT cannot give you reliable sources in the state it's in. But also to help write grant application, or for example, here to edit a manuscript. So the question is, how are we going to let a large language model enter our scientific processes, even if it's, for example, writing rejection letters when you're an editor? I've seen people doing that. Is it going to write a part of your article? It's just a question. Like today we're at this time where, we don't know, and that's a big issue for scientific integrity. And one last thing is, I think for me right now as a research librarian, the biggest issue for me linked to library science is, should we cite large language model? Are they a source? And so here you have two different universities, University of Waterloo and the Western Australia University, giving you two ways to actually cite APA style the use of ChatGPT, and they actually differ, because in one case you actually, in the case of Waterloo, they tell you to actually give the prompt, the access date, etc. When on the right side, they don't tell you to give the prompt. But the thing is, and some people argue, it's kind of the same thing as saying, I've seen on the internet or I've seen on TV. Without the prompt, it doesn't really mean anything. And even with the prompt, the fact that the conversational model of ChatGPT actually learns, not GPT, but ChatGPT does, the conversational layer, makes that you're not going to have the same answer from one week to another. So can this be a source? Is it a source? And that's a real question. And for now, I think we don't have an answer to that, because in terms of scientific integrity, we should cite our sources, but is it a source? And so it asks a lot of different questions that we're not ready to answer because it's brand new, but I think are pretty interesting for scientific integrity purposes. And that's pretty much it for me. I think that was already a lot.